Hello, this is video 15.2. We'll be talking about how to find the volume of a rectangular prism. Okay, so we're going to be covering standard G2. I can find the volume of a right rectangular prism by multiplying the edge lengths using the formula V, or volume, equals length times width times height, L times W times H. Or you can look at it in terms of volume is equal to the area of the base. So use the formula for the area of the base, whatever that shape is, and you multiply that by the height. So here's some definitions. So what is volume? Go on to there. I'm going to grab my little spotlight. Volume is the amount of space enclosed within a container. So far we've only looked at two-dimensional area. So let's take a look at the difference. So if I have area, it's how many flat square cubes will fit inside a flat side of the container. So for instance, here's my cubes, and I'm going to look at this, just the one side of this container. So just this side right here. How many of these flat cubes, or not cubes, flat squares, will fit on the flat surface of the side of this container? So I could keep going and I could put a million of these, right? I could put, well, not a million, but I could keep going until I fill the whole side up with yellow squares, correct? Yeah. So that's what area is. It's how many of these squares of a certain size, 1 inch by 1 inch or 1 centimeter by 1 centimeter, how many of those squares will fit on the flat surface of the side of this container? So compare that to volume. Volume is different. Volume is how much can fit inside of the container, and not just the flat squares now. Let me move my squares here and get those out of there. Now we're talking about inside the container. Now I don't have a way to show you inside, but you're looking at cubes now. A three-dimensional cube. How many of these cubes are going to fit inside of this container? So I could keep stacking them up all the way to the top, like this. And by the way, I have my hat on because I was outside earlier today and I was running, so just kept my hat on for the day. Let's see. In case you're wondering why I'm wearing a hat. So I would just keep filling this up, and I would start another row here, and then I could start going this way with them, and I could fill them up here. How many of these cubes would fit inside the container? So that's what volume is. It's cubes. Area is a flat two-dimensional surface, figuring out how many two flat two-dimensional squares will fit on the face of a container. So I can grab these and move these back. Or I could just leave them. Actually, I'll just leave them. Okay, let's go on and look at what is a face. Well, a face is the side of the container, or it could be the top, or it could be the bottom of the container. The base, actually, this one right here, the base could be the bottom or the top, or it could be the left or the right. It's the opposite faces of a prism. So if I go back up here for a minute, so we know that this top and this bottom that you can't see are faces because they're opposite of each other, they're bases. This right side and the left side that you can't see, those are also bases because they're opposite of each other. And you could also say this front piece here and then the back piece that you can't see. Those two are bases because they are opposite of each other. What is a rectangular prism? It is a three-dimensional object with 6 faces that are all rectangles. Okay, mine is not exactly a rectangular prism because I've got a square up on top. So if I was going to make it a rectangular prism, I'd have to kind of stretch it out a little bit more and make it more of a rectangle. Now it's starting to look more like a square. But a rectangular prism has all faces that are rectangles, and it's three-dimensional. So how do we find volume? We talked about it. There's a couple of easy ways. So far you've learned that the volume of like a square, for instance, is length times width, right? Or base times height. So if this is a square right here, and then the bottom would also be a square. That's your base. So the area of just the bottom is length times width, right? So to find the volume, how much stuff fits inside of that container that has a square base, you would say length times width times height. So you're just adding a new dimension. So you're adding this height. So far you've done length and you've done width, and now you also have height. So that's one way. That is basically the same formula both ways. Multiply its length times width times height for a rectangular prism. It's different for different shaped containers. So if you had a round base, you would find the area formula for a circle, which we haven't talked about yet, and you would multiply that by the height. If you had a triangular base, you would find the area of the triangle base and then multiply it by the height. So you can see that it's pretty easy to do volume if you have memorized the shape formulas for area. So now I want to draw the figure on page 427, number 2. So let me draw that, and I'll come right back to you after I get it drawn so we don't waste time on the video. Okay, I drew the picture on my Microsoft Word document here. This is page 427, number 2. So we're going to take a look at this, and we are going to find the volume of this figure. So to find the volume, we have to use the formula volume equals, remember, length times width times height. And a lot of times you won't see the times symbol in between. You'll just see it like this. Volume equals LWH. And that means to times. When you have two variables next to each other, two letters, or 3 letters, or 4 letters, it means to multiply those letters together if there was a number put in for them. So we have everything we need. What is our length? This is our length, right? So that's 7.5. This here is our width, that's 4, and this here is our height, that's 2.5. So let's go ahead and put that in, and we're going to multiply that out. So we have 7 1/2 times, and I'm putting the times in there so we know, 4 times 2.5, right? 2.5. Length times width times height. Now we got to remember all our fraction rules. So we can do whole number. Let me grab my spotlight. Whole number times the bottom plus the top. So 7 times 2, 14 plus 1, 15. So where'd my tool go? That's 15 halves. We're going to rewrite it like that. 15 halves. And for those of you who like decimals, you're welcome to put it as 7.5 if you prefer. And then it's times 4, and I'm going to make it times 4 over 1 because we're talking about fractions. So isn't 4 over 1 the same as 4? Yes. And then times whole number times the bottom plus the top. Whole number times the bottom plus the top. Clap, clap. Whole number times the bottom plus the top. Clap, clap. So we get 2 times 2 plus 1. 5 over what number? 2. Okay. Now, can we cancel anything? Well, a little bit, right? Take a look and see. I'm going to change colors so we can see what we're canceling. Well, the 2 will go into the 4, right? So I'm going to cross off the 4. 4 divided by 2 is 2. 2 divided by 2 is 1. We did a little bit of canceling, not a lot. So now we're going to get 15 on the top times 2 times 5. And on the bottom, should have made a straight line. We have 2 times 1 times 1. 2 times 1 times 1. And now we have to multiply that out. Well, 15 times 2 is 30. 30 times 5, 150. So 150 is my top number. And my bottom number is 2 times 1 times 1, or 2. Now I'm not quite done, right? I still have to do my division, because 150 is really a mixed number divided by 2, right? So where can I do that? Right here, I guess we'll have enough room. 150 divided by 2. Remember, the top number is always on the inside. So how many 2's go into 15? 2 times 7, try to make that small. 2 times 7 is 14. 15 minus 14 is 1. Bring down my 0. It's supposed to be an arrow. 2 goes into 10 5 times. 2 times 5 is 10, and if I subtract, I end up with a remainder of 0, way at the very bottom of my screen there. So the answer then is, what is the volume of this right rectangular prism? The volume is, what do you think? Yes, 75. 75 what? Should I write inches? But this time we're talking about 3 dimensions, right? What did we do when we did area? We had a little 2 by the unit of measure, right? This time now we have 3 measurements, so we put a little 3 there. We're talking about 75 inches cubed, or another way of writing this that you'll see when you talk about volume is 75 cubic, because remember they're cubes. How many cubes fit into a container that's that size with those dimensions? 75 cubic inches. So if I had cubes that were 1 inch by 1 inch, I could fit 75 into this size container. Okay. So now I want to go to page 428. If you need to pause the video, I'm going to clear my drawings here. And then I need you to be on page 428. We're going to go over the whole page. So going, gone. And let's pull up page 428. It's over here. There it is. And close that. We want to make it that big. I think we're going to have to make it, well, let's try it this big and see if we've got a little bit of room. I'm going to move myself, I don't know, maybe way up in that corner. Okay. A large cube is made up of smaller unit cubes as shown on the right. Each small cube has an edge length of 1/2 of a unit. So what are they saying? Well, you can see that this whole big cube looks like a Rubik's Cube, except it's got an extra row. This whole big cube has little cubes inside, and each one of these little cubes, it says, has a length of 1/2. So let's mark that. Always in geometry, you want to mark your drawings, or you want to draw your drawings and then label them. So each one of these little cubes has a length of 1/2. So I'm going to draw 1/2 for each of these, and the last one is 1/2 as well, right? So it says each edge of the large, key word here is the large cube, is blank units. Well, each small cube, and grab my spotlight, the length is 1/2. So how long is the whole side right here? That whole edge. How would you figure that out? Exactly, 1/2 plus 1/2 plus 1/2 plus 1/2. Well, what does 1/2 plus 1/2 plus 1/2 plus 1/2 equal? Well, that should equal 4 halves, right? And 4 halves is the same as 4 divided by 2. 4 divided by 2. And we all know what 4 divided by 2 is. Exactly, it's 2. So the edge of the large cube is 2 units. Very good. What is the volume of the large cube? Remember what our formula for volume was? Volume is equal to length times width times height, right? So we have to figure out, well, we know the length. We just figured it out. It was 2, right? The length of the big cube is 2. What's the width of the big cube? This part right here. Grab my spotlight. The width would be this right here. What is that? Well, how many cubes do you have? 1, 2, 3, 4. And each cube is half a unit. So again, you have a half plus a half plus a half plus a half. So you're going to have a total of 2 units for the length, or the width, I'm sorry, of this big cube. And what about the height? The height is the distance up, right? What is the height of that cube? Well, how many squares you got? 1, 2, 3, 4. So they're each a half. Half plus a half plus a half plus a half. Again, 2. And you probably already know that and said that. You're like, yeah, I know that. So now we've got our length, we've got our width, we've got our height. So it's going to be 2 times 2 times 2. So we got to go by the first 2. 2 times 2 is 4. So 2 times 2 is 4. And then we have to times that by the other 2. 4 times 2 is 8. So the answer is 8 cubic units. So far, so good? Okay, I'm going to clear my screen. So if you need to get this down and pause, go ahead. Going, gone. Okay, let's look at number 3. Number 3 says, find the volume of each prism. Okay, we know that volume is length times width times height. So we just plug in the numbers. We have a length of 10. What is our width? 3.2. What is our height? 5. So then we have to multiply those all together. So the best way, I think, is let's do 3.2 times 5 first. Times, and I know it's easy to use a calculator, but I still want you guys to get used to being able to multiply decimals and fractions and things like that. Next year, halfway through 7th grade, then you can start using a calculator. So I'd like you to do it without right now. So 2 times 5 is 10. Down the 0, carry the 1. 3 times 5 is 15, plus 1 more is 16. How many numbers do we have after a decimal? Between the two numbers, we have 1 number after the decimal, so we have to jump 1 spot and put our decimal right there. So the answer then, well, we're not done yet. Still got 1 more thing to multiply, right? But so far we're at 16, so let's change colors now. So now we know this is 16.0, which is really just 16, right? And we still have to multiply by the 10 over here, right? We still got this 10 we haven't multiplied by. So now it's 16 times 10. And that's a bad 10, but that's what it is. So I put my 0 down. 6 times 1 is 6. 1 times 1 is 1. So the cubic meters is 160. Let me double check that I got that. Yes, 160 cubic meters. Okay, that's how many cubes 1 meter by 1 meter by 1 meter will fit inside of our rectangular prism here. Okay, so I'm going to clear my screen again. If you need to pause, go ahead. Going, gone. Okay, number 4. We have another rectangular prism with different lengths here. This one is asking us to do length times width times height again. It's just saying it in a different way. It's saying figure out the base and then multiply by the height is what it's trying to tell you to do. But we're just going to use the one formula. So it's length times width times height. Finding the volume. Volume equals, so we have 7 1/4 7, I keep turning my little heater on and then I get too hot and I turn it off again. I'm going to turn it off. There we go. 7 1/4 times 4. And I might as well just write 4 over 1 right away, right? Yeah. Times 8. And we'll just put it 8 over 1. Now we're almost ready to multiply. We just have to change our mixed number into an improper fraction using our whole number times the bottom plus the top. Whole number times the bottom, 7 times 4, 28, plus the top, 29, 29 fourths, right? Fourths on the bottom, 29 fourths. And then again, we have times 4 over 1 and times 8 over 1. Can we cancel anything? Change my color here. We can cancel the 4s if we would like. They become 1s. We could also put the 4 into the 8 if we wanted. We'll do that. And now we're left with, go back to the blue, 29 times 1 times 8. So 29 times 1 times 8 on the top. And on the bottom, that's pretty easy. We got 1 times 1 times 1, or just 1, right? So we basically have to multiply 29 times 8. Because the 1 will, we can drop the 1. 29 times 8. 9 times 8, yes, 72. Carry the 7. 2 times 8, 16, plus 7, 17, 18, 19, 20, 21, 22, 23, right? 232 is my answer. So how many cubic meters do I have? I have 232 cubic meters. Okay, not too bad, right? Just a little bit of the manipulating with fractions. All right, clearing this. So if you need to pause, go ahead. Okay. Number 5, let's scroll up if we can. Yes, we can. Number 5 and 6, we're going to be doing the same kind of thing. This time we have decimals to multiply, so we're going to be multiplying 9.25 times 4 times 7.5. So let's just do 9.25 times 4 first. So 4 times 5 is 20. Carry my 2. 2 times 4 is 8, plus 2 more is 10. Put down the 0, carry my 1. 4 times 9 is 36, plus 1 is 37. Now we have to see how many numbers after the decimal we have. We have 2 numbers after the decimal. So we have to jump. I'll change colors here. We have to jump our decimal 2 over right here. So that's 37.00, or just 37. We're not quite done yet. We now have to multiply our 37 times, what's the number we haven't used yet? The height, right? 7.5. So 7.5, that's a bad 7. I'm gonna make it a little better. There we go. Multiply that, we get 5 times 7 is 35. Carry the 3. 3 times 5 is 15, plus 3 more, 16, 17, 18. Second row, it's 8. 7 times 7 is 49. Make sure the 9 gets put under the 7. And we're going to carry the 4. I cross off the old carry number. 7 times 3, 21, plus 4, 22, 3 to 4, 25. And then I add that all up like this. So we get 5 plus nothing is 5. 9 plus 8 is 17. Carry the 1. 5, 6, 7. And then a 2. And then how many numbers after our decimal? We just have one number here, right? So that means we have to move our decimal 1 place over to right here. So the answer for number 5, the volume of our rectangular prism is 277.5 cubic feet. Okay. And I can leave that there. I just got to get rid of this. And let's look at the last one here, number 6. Oh, no, that's not the last one. But okay, number 6, we have volume of this prism, 18 times 4.5 times 6.5. So we're going to write this like this, 18 times 4.5. And let's take 4.5 right here, and let's make it an improper fraction right away. So 4 times 2 is 8, plus 1 is 9. So we'll put 9 halves. And I'm going to go ahead and put the 18 over a 1 here right away. Times, let's take this number here and make that an improper fraction. 6 times 2, 12, plus 1, 13. So 13 over 2. Now, is there anything we can cancel out? Anything at all? See anything we can cancel? I do. I see a different color. The 2 will go into 18, because 2 times 9 is 18, right? And 2 will go into itself 1 time. So now I've eliminated a little bit there. Now I can multiply 9 times 13. So 9 times 9 I already know is 81, right? So I can just multiply 81 times 13, right? So 81 times the 13 over here. And then that'll be my top number. So 3 times 1 is 3. 3 times 8 is 24. And then the next set here, 1 times 1 is 1. 1 times 8 is 8. And then I add those together, and I get 3. 4 plus 1 is 5. Hopefully you're writing this in your book at the same time and not taking a little nap. 8 plus 2 is 10, right? Okay, so 1053 on the top. What do we have on the bottom? We have a 1 times a 1 times a 2. So that would be 2. So it's going to be 1053 divided by 2. Let's make sure that's what I got on my book. I think I did when I did this. Yep. So now our last step is to do long division. Top number goes on the inside. 1053 divided by 2. Okay, so 2 goes into 10 5 times. 2 times 5 is 10. Subtract 10 minus 10 is 0. We're going to bring down the 5. So now we have 2 into 5. How many 2's go into 5? Yep, 2. 2 times 2 is 4. 5 minus 4 is 1. Bring down our 3. How many 2's go into 13? 6. 2 times 6 is 12. I'm run out of room, but not quite. We're going to get it. 13 minus 12 is 1. Remember what we can do now? Put a decimal here and a 0. Put a decimal here above it. Put a 0 here and bring down another number, right? A 0. So now if I bring down the 0, you can see that 2 goes into 10 5 times. And then 2 times 5 will be 10. And 10 minus 10 will subtract to 0 and we'll have no remainder left. So the answer is 526.5 or 526 and 5/10 cubic inches. So let's write that in there. Let's get rid of some of this other stuff for the moment so we don't have too much. And let's write down 526? 520. And by the way, you should be showing some of your work here on your page when you turn it into me. 526.5 cubic inches. Okay. Number 7, and we'll let you try that on your own just because I don't want the video to get too long. Let's clear our stuff. So number 7 says, a cereal box is 8.5 inches long, 3.5 inches wide, and 12 inches high. What is the volume? You're going to multiply those 3 numbers together. So give that one a try at home. Number 8, which 2 formulas can you use to find the volume of a rectangular prism? They wanted to say the 2 formulas they wanted you to do is volume equals length times width times height, or volume equals area of base times the height. So those are your 2 formulas. Just knowing volume equals length times width times height is enough for now. When you get into 7th and 8th grade, then we'll look more at the idea of the base times the height. Okay, homework. Let me go back to this. Homework, I want to clear my drawings, I guess, is to do page 429 through 430, numbers 9 through 16. I'm going to give you some helpful hints on a few of these. Let me just turn my book page over here. So I'm going to give you some hints for number 13. So let's look at that one. Number 13, I could bring it up. Let's bring it up here. 429. And then I will bring this back up and make it smaller. And then this has to be turned the right way. Okay. So number 13, and I want to make that small, not big. And we don't want to have this extra little stuff in there. Okay. So number 13 says, a company is designing a juice box. The box is the shape of a rectangular prism. The base of the box is 6.5 inches by 2.5 inches, and the box is 4 inches high. If juice fills 90% of the box's volume, find the volume of juice in the box. So here are your hints for this. So you're going to use your volume formula to find the volume. So find your volume using length times width times height, and then that's going to equal something, right? Then you're going to take your question mark, your answer, how did I say this? Multiply your volume answer times 0.90. 90%, you haven't learned that, you'll learn that more next year, but 90% means to move your decimal 2 places to the left, so 0.90. So that's what you're multiplying your answer by, 0.90, once you get your volume, okay? That's your hint. What other one do I want to give you a hint on? Number 14. Number 14, your hint for that one, let's read it. Density is the amount of mass in a certain volume of an object. You're going to learn that in 8th grade physical science. To find the density in grams per cubic centimeter of a substance, you can use the relationship density equals mass in grams divided by volume in cubic centimeters. Is there more? Yes. A gold bar that is 16 centimeters by 2.5 centimeters by 5 centimeters has a density of 19.3 grams per cubic centimeter. What is the mass of the gold bar? Ay, right? Well, first I think you should draw your shape when you do this. Where's that dimensional box? Here we are. So first you would like to draw your shape, okay? And it's a gold bar. So it gives us the dimensions, so I would label the dimensions. I would say, well, this is going to be 16, and it doesn't matter which one you label what because they all multiply together anyway. 16, and then we have 2.5. This isn't going to, 2.5 can be this one, the width. And the height, did it tell you which one was the height? Yeah, 4 inches was the height. Did it say the width was 2.5? Yeah. So there we are. We've labeled it, and that's in inches, right? So we could put our little inch mark if we wanted to remember what units we're using. And then we have to do 2 things. We have to do step 1. Step 1 is to find the volume. Find volume. How do you do that? length times width times height, right? And then step 2 in this case is we have to do, we have to use that formula they gave us, mass in grams divided by volume in cubic centimeters. So let me just show you a little thing here that you could use. If I had a triangle, I'll make a triangle up here. Wait a minute, I'm going to make a triangle over here. If I close this out, there, a little bit more room now. So if I make a triangle, I'm going to show you this. You can do this with any proportional formula. And I'll show you what it means. So in the top of the triangle will be mass. And I've shown this to my 8th graders. So this will be very handy for you. Mass goes there. Density goes here. And volume goes here. So now what you do is, let me grab a box here. I want to make it a white box. So if you're looking for, and our problem is looking for what? What is our problem looking for? Our problem, hopefully I can see that now. Our problem is looking for, what was it looking for? Density, I think. Go back to it. I don't want to scroll up on it right now. It was looking for what is the mass of the gold bar. So it's looking for the mass. And it gave you our formula. Mass is on the top. So if you're looking for mass, you take mass and you cover it up. Okay? And you have left density and volume. Okay? So what this means, I'll move the box away. So let's say I was looking for the density. Then I'd cover density up. So this means mass divided by volume. If I was looking for the volume, I'd cover the V up, and then it would be mass divided by density. I'm looking for the mass, so that means density times volume. Remember how I said 2 letters next to each other means multiply them? So I have to multiply the density times the volume to find the mass, which is what I'm looking for. So step 2 then is to multiply the volume that I found in step 1 times the density, which I believe is given in the problem. Yes, they tell you the density is 19.3. So that's how you'll solve that. I can scroll this up a little now. So step 1, find the volume of this picture here that we drew. Step 2 is multiply the volume that you get in the answer times the density, which we found in the problem to be, change colors here, to be right here, 19.3 grams. Okay, multiply volume times 19.3. So that's a hint for 14. That's kind of a toughie. And then the next one I want to give you a hint for is 16A. So let me bring that page up and then we will be all done. So hopefully you paid attention and you learned something, right? Okay. So let's clear our drawings. And a helpful hint for number 16A. So let's read it. The Smith family is moving and needs to decide on the size of the moving truck they should rent. And then there's this lovely little box chart thing here that tells you what size the van would be, like how much space is inside of it, the length times the width times the height. A small truck has this length, width, and height, and then a large truck has this length, width, and height. Okay? So the Smith family is moving and has to decide on the size of the moving truck they should rent. A moving van rents for $94.50. So the van here is $94.50. And a small truck, this one here, rents for $162 per day. Based on the amount of space inside the van or truck, that's volume, which is a better deal? Explain your answer. Okay, so what are you going to do? So your step 1 for number 16 is to find the, I'll put the steps. Step 1, find the volume of the van. Okay. Step 2 is to find the volume of the small truck. Okay, so far so good. You know how to find volume, right? Length times width times height. It's all given there for you in that chart. And then you have to figure out the per unit cost for the van and for the small truck. So step 3, you are going to divide cost by the volume you find. Okay, for both the van. So for the van, and then step 4, you are going to divide the cost by the volume for the small truck. So the cost is given to you in the problem. The van costs $94.50. You're going to divide that by the volume you find for the van. The small truck is $162. You're going to divide that by the volume you find for the small truck. Then you're going to compare. So that's the final step. Step 5 is to compare step 3 and step 4 answers. Okay, so decide which one is a better deal, okay, based on what you get in step 3 and 4. Okay, B says how much greater is the volume of the large truck than the volume of the small truck. You're going to figure out the volume of the large truck and compare it to the volume of the small truck and subtract. The family estimates that they need about 1,100 cubic feet to move their belongings. What should they rent? So you're going to have to know the volume of the van, small truck, and large truck by letter C. You'll have already figured out all 3 of them. So you'll be able to compare and decide which one's the best one for the family. Okay, I'm going to stop my sharing and I'm going to say goodbye for now and let me know if you have any questions, and we will see you next time. Bye-bye.